Hello friends, welcome back to i-TUTOR NCERT series. Today we are going to discuss Class 11 Geography NCERT Fundamentals of Physical Geography Chapter 3 Interior of the Earth. The interior of the Earth can be understood only by indirect evidences as neither anyone has nor anyone can reach the interior of the Earth. Okay, so we are understand the interior of the Earth by the indirect evidences. The configuration of the surface of the Earth is largely a product of processes operating in the interior of the Earth. Exogenic as well as endogenic processes are constantly shaping the landscape. A proper understanding of the physiographic characters of a region remains incomplete if the effects of endogenic processes are ignored. Human life is largely influenced by the physiography of the region. Therefore, it is necessary that one gets acquainted with the force that influence landscape development. To understand why the earth shakes or how a tsunami wave is generated, it is necessary that we know certain details of the interior of the earth. Okay, so in this chapter, we are going to discuss about the interior of the earth. Okay, the earth forming materials have been distributed in the form of layers from the crust to core. Okay, so we know there is three parts. First one, crust, then mantle and core. The sources of information about the interior. The Earth's radius is about 6,378 km. No one can reach the center of the Earth and make observation or collect samples of the materials. Why? Do you know why? Because there is very much pressure and temperature. Most of our knowledge about the interior of the Earth is largely based on estimates and inference. Yet, a part of information is obtained through direct observation and analysis of the material. Okay, so let's check what are the direct sources. The most easily available solid earth material is the surface rocks. Okay, surface rocks or the rocks we get from the mining areas. Okay, so that is called surface rocks. Gold mines in South Africa are as deep as 3 to 4 km, and going beyond this depth is not possible as it is very hot at the depth. Besides mining, scientists have taken up a number of projects to penetrate deeper depths to explore the condition in the crustal portions. Scientists world over are working on two major projects such as Deep Ocean Drilling Project. Okay, the first one is Deep Ocean Drilling Project and the Integrated Ocean Drilling Project. Okay, so these are two projects which scientists are working hard for to find the interior of Earth. The deepest drill at Kola in Arctic Ocean has so far reached a depth of 12 km. Okay, so this is the deepest drill in the world, that is Kola in Arctic Ocean. This and many deep drilling projects have provided a large volume of information through the analysis of materials collected at different depths. Volcanic eruptions forms another source of obtaining direct information. Okay, so second one is the volcanic eruptions. Okay, they also provide very much information about the interior of Earth. As and when the molten material that is called magma is thrown onto the surface of the Earth during volcanic eruption, it becomes available for laboratory analysis. However, it is difficult to ascertain the depth of the source of such magma. Now, next one is indirect sources. Okay, so now we already discussed about the direct sources. That is, first one, the rocks, surface rocks or the mining rocks. Then second one is deep drilling projects. Okay, now indirect sources. Analysis of properties of matter indirectly provides information about the interior. We know through the mining activity that temperature and pressure increases with the increasing distance from the surface towards the interior in deeper depth. Moreover, it is also known that the density of the material also increases with the depth. Okay, what happened? The density increases with increasing depth. Again, also the temperature and pressure increases with increasing distance from the surface. It is possible to find the rate of change of these characteristics. Knowing the total thickness of the Earth, scientists have already estimated the values of temperature, pressure and the density of materials at different depths. Next one. Another source of information are the meteors that at time reach the Earth. However, it may be noted that The material that becomes available for analysis from meteors is not from the interior of the earth. Okay, so they are not from the interior of the earth. The materials and the structure observed in the meteors are similar to that of the earth. They are solid bodies developed out of material same as or similar to our planet. Okay, so these meteors may be similar to our planet. Hence, this becomes yet another source of information about the interior of earth. Okay, so the meteors are another source of information. The other indirect sources including gravitation, magnetic field and seismic activity. Okay, so the next one is gravitation, magnetic field and seismic activity. The gravitation force, that is G, is not the same at different latitudes on the surface. It is greater near the poles and less at the equator. This is because of the distance from the center at the equator being greater than at the poles. Okay, because the distance from the center at the equator, that is greater than the poles. Okay, the gravity values also differ according to the mass of material. Okay, gravities also differ because of the differ according to the mass of material. The uneven distribution of mass of material within the earth influences this value. The reading of gravity at different places is influenced by many other factors. These readings differ from expected values. Such a difference is called gravity anomaly. Okay, so this difference is called gravity anomaly. Gravity anomalies give us information about the distribution of mass of the material in the crust of the earth. Magnetic surveys also provide information about the distribution of magnetic materials in the crustal portion and thus provide information about the distribution of materials in this part. Seismic activity is one of the most important sources of information about the interior of the earth. Okay, now next one is earthquake. What is earthquake? The study of seismic waves provide a complete picture of the layered interior. An earthquake in simple words is the shaking of earth. Okay, so what is earthquake? It's the shaking of earth. It's a natural event. It is caused due to release of energy which generates waves that travel in all directions. Okay, so it's a natural event and it's caused due to the release of energy which generates waves that travel in all directions. Why does the earth shake? The release of energy occurs along a fault. A fault is a sharp beak in the crustal rocks. Okay, so the release of energy occurs along a fault. And what is a fault? It's a sharp break in the crustal rocks. Rocks along a fault tend to move in opposite directions. As the overlying rock strata press them, the friction locks them together. However, the tendency to move apart at some point of time overcomes the friction. Okay, when the tendency to move apart at some points, this overcomes the friction. As a result, the blocks get deformed and eventually they slide past one another abruptly. This causes a release of energy and the energy was travel in all directions. The point where the energy is released is called focus. Okay, so the point where the energy is released, this is called focus. Okay, focus of an earthquake. Alternatively, it is also called hypocenter. Okay, alternatively, it is called hypocenter, a focus or hypocenter. The energy waves traveling in different directions reach the surface. The point on the surface nearer to the focus is called epicenter. Okay, so the point where the energy released is called focus and the point on the surface nearest to the focus, that is called epicenter. It is the first one to experience the waves. Okay, so the epicenter is the first one to experience the wave. It is a point directly above the focus. Okay, so if this is the focus, this is inside the earth. Okay, if it is the focus, then this is the epicenter. Okay, directly above the focus. Now, earthquake waves. All natural earthquakes take place in lithosphere. Okay, so normally all the natural earthquakes take place in the lithosphere. It is sufficient to note here that the lithosphere refers to a portion of depth up to 200 km from the surface of Earth. Okay, so the lithosphere means it is from 200 kilometers from the surface of Earth. An instrument called seismograph records the waves reaching the surface. A curve of earthquake waves recorded on the seismograph is note that the curve shows three distinct sections, each representing different types of wave pattern. Earthquake waves are basically of two types, body waves and surface waves. Okay, so there are two types of earthquake waves. First one is body waves and next one is surface waves. Body waves are generated due to the release of energy at the focus and move in all directions, traveling through the body of the earth. Okay, so as the name denotes, the body waves are traveling through the body of the earth. Hence, the name body waves. Okay, so that's why the name body waves, because they're traveling through the body of the earth. The body waves interact with the surface rocks. Okay, so these body waves interact with the surface rocks. Okay, and generate new sets of wave that is called surface waves. Okay, so when the body waves interact with the surface rocks and they generate new set of waves that is called surface waves. Okay, these waves move along the surface. Okay, so these surface waves move along the surface. The velocity of waves changes as they travel through materials with different densities. The denser material, the light higher is the velocity. Okay, so the denser material, the higher is the velocity. Okay, if the density is high, then the velocity is also high. The direction also changes as they reflect or refract when coming across materials with different densities. Now, so we discussed about two types of wave, that is body waves and surface waves. Now, there are two types of body waves. Okay, the body waves are then further classified into two types, that is P and S waves. Sorry, P and S waves. P waves move faster and are first to arrive the surface. Okay, so the P waves are move faster and they are the first to arrive at the surface. These are also called primary waves. Okay, the P waves or primary waves. The P waves are similar to sound waves. Okay, so these are similar to sound waves because they travel through gaseous, liquid and solid materials. Okay, these P waves travel through the gaseous material, liquid materials and solid material. Now, S waves arrive at the surface with some time lag. Okay, so S wave reaches second. Okay, that is it takes some time to reach the surface. Arrive at the surface with some time lag. These are called secondary waves. Okay, so the body waves are of two types, that is P waves and S waves. The P wave is also known as primary wave and they are move faster than surface waves are. Surface wave reach the S wave or secondary waves, they reach the surface with some time lag. An important fact about S wave is that they can travel only through solid material. Okay, so the S wave can only travel through solid material. P waves can travel through solid, liquid or gaseous. This characteristics of S wave is quite important. It has helped scientists to understand the structure of the interior of Earth. Okay, so these characteristics help the scientists to understand the structure of interior of the Earth. Reflection causes waves to rebound, whereas refraction makes waves move in different direction. The variation in the direction of waves are inferred with the help of their record on seismograph. The surface waves are the last to report on seismograph. Okay, so the surface waves are last record on the seismograph. These waves are more destructive. Okay, so the surface waves are more destructive also. They cause displacement of rocks and hence the collapse of structure occurs. Okay, they cause the displacement of rocks and it also collapse the structures. Now, moving forward, propagation of earthquake waves. Different types of earthquake waves travel in different manners. As they move or propagate, they cause vibration in the body of the rocks which they passes. Okay, so they cause vibration on the body which they pass. And the P waves vibrate parallel to the direction of the wave. This exerts pressure on the material in the direction of the propagation. As a result, it creates density differences in material leading to stretching and squeezing of the material. Other three waves vibrate perpendicular to the direction of propagation. Okay, so the P wave vibrate parallel to the direction of propagation and the other three waves, they are perpendicular to the direction of propagation. The direction of vibrations of S waves is perpendicular to the wave direction in the vertical plane. Hence, they create troughs and crusts in the material through which they pass. Surface waves are considered to be the most damaging waves. Okay, so we already discussed that surface waves are the most damaging waves. Now, emergence of shadow zone. Earthquake waves get recorded in seismograph located at far-off locations. However, there exist some specific areas where the waves are not reported. Such a zone is called the shadow zone. Okay, so shadow zone is those zone which does not reported the waves, earthquake waves. Okay. The study of different events reveals that for each earthquake there exists an altogether different shadow zones. It was observed that seismographs located at any distance within 105 degree from the epicenter recorded the arrival of both P and S waves. However, the seismograph located beyond 145 degree from epicenter record the arrival of P waves but not S waves. Okay, so in 105 degree of the epicenter they recorded the arrival of both P and S waves, but in seismograph located beyond 145 degree from the epicenter it record only P waves but not the S waves. This is a zone between 105 degree and 145 degree from epicenter was identified as the shadow zone for both the types of waves. Okay, so between 105 degree and 145 degree from the epicenter, that region is known as shadow zone for both the types of wave. The entire zone beyond 105 degree does not receive S waves. The shadow zone of S wave is much larger than that of P waves. Okay, so the shadow zone of S wave is much larger than that of the P waves. The shadow zone of P waves appears as a band around the earth between 105 degree and 145 degree away from the epicenter. Okay, look at this picture. This is P wave shadow zone and this is also P wave shadow zone. Now, look at this. This is S wave shadow zone, that is 105 to 100. This is 105 degree here. Okay, this is S wave shadow zone. These shaded regions. Here 105 to 145 there is P wave shadow zone. Okay, here also the S wave shadow zone. This is also S wave shadow zone, 105 to 145. But this is here we can receive the P waves, but we can't receive S wave here. Okay. Now, the shadow zone of S wave is not only larger in extent, but it is also a little over 40% of the Earth's surface. Now, types of earthquake. The most common ones are the tectonic earthquakes. These are generated due to sliding of rocks along the fault plane. Okay, so what is tectonic earthquake? These are generated due to sliding of rocks along the fault plane. Now, a special case of tectonic earthquake is sometimes recognized as volcanic earthquake. However, these are confined to areas of active volcanoes. Okay, so the volcanic earthquakes are only confined to the areas of active volcanoes. Third one, the areas of intense mining activity. Sometimes the roofs of underground mines collapse, causing minor tremors, and these are called collapse earthquake. Now, ground shaking may also occur due to explosion of the chemicals or nuclear devices. Such tremors are called explosion earthquake, and the earthquake that occur in the areas of large reservoirs are referred to as reservoir induced earthquake. Okay, so these are some of the types of earthquake. Now, measuring earthquakes. The earthquake events are scaled either according to the magnitude or intensity of the shock. The magnitude scale is known as the Richter scale. Okay, so the magnitude scale is known as Richter scale. The magnitude relates to the energy released during the quake. The magnitude is expressed in numbers, that is 0 to 10. The intensity scale is named after Mercalli, an Italian seismologist. The intensity scale takes into account the visible damage caused by the event. The range of intensity scale is from 1 to 12. Now, effect of earthquake. Earthquake is a natural hazard, and following are the immediate hazard effect of the earthquake. ground shaking, differential ground settlement, land and mudslides, soil liquefaction, ground lurching, avalanches, ground displacement, floods from dam and levees failure, fires, structure collapse, falling objects, tsunami. Okay, so these are some of the immediate hazardous effects of earthquake. Now, the first 6 listed above have some bearing upon landforms. Okay, that is the first 6 till this avalanches. Okay, so they have some bearing upon landforms, while others may be considered the effects causing immediate concern to the life and properties of people in the region. The effect of tsunami would occur only if the epicenter of the tremor is below oceanic water and the magnitude is sufficiently high. Okay, so the tsunami would occur only if the epicenter of the tremor is below oceanic waters and the magnitude is sufficiently high. Tsunamis are waves generated by the tremors and not an earthquake itself. Though the actual quake activity lasts for a few seconds, its effects are devastating provided the magnitude of the quake in more than 5 on the Richter scale. Now, frequency of earthquake occurrences. The earthquake is a natural hazard. If a tremor of high magnitude takes place, it can cause heavy damage to the life and property of people. However, not all the parts of the globe necessarily experience major shocks. Note that the quakes of high magnitude, that is 8+, are quite rare. They occur only 1 to 2 years, whereas those of tiny types occur almost every minute. Okay, so the high earthquakes are very rare, but the tiny types, they occur almost every minute, but we can't feel that. Okay, now structure of the earth. So the first one is, we know the earth has 3 layers. First one is the crust. It is the outermost solid part of the earth. It is brittle in nature. The thickness of the crust varies under the oceanic and continental areas. Okay, oceanic crust is thinner as compared to continental crust. So oceanic crust is the thinner one. The mean thickness of oceanic crust is 5 km, whereas that of the continental is around 30 km. Okay, so if this is the crust portion, this is oceanic crust and this is continental crust. So the continental crust is 30 km, whereas the oceanic crust is only 5 km. Okay, this crust portion. So next one is mantle and finally core. Okay, now this is only crust portion. Now the continental crust is thicker in the areas of major mountain systems. It is as much as 70 km thick in the Himalayan region. Okay, so it's 70 km thick in the Himalayan region. Next one is mantle. The portion of the interior beyond the crust is called mantle. Okay, so portion interior beyond the crust, that portion is called mantle. The mantle extends from Mohos discontinuity to a depth of 2900 km. The upper portion of the mantle is called asthenosphere. The word astheno means weak. It is considered to be extending up to 400 km. It is the main source of magma that finds its way to the surface during volcanic eruption. The crust and uppermost part of the mantle are called lithosphere. Okay, so what is lithosphere? The crust and the uppermost part of mantle. So this is called lithosphere. Its thickness ranges from 10 to 200 km. The lower mantle extends beyond the asthenosphere and it's a solid state. Okay, so the lower mantle extends beyond the asthenosphere and it is in the solid state. Now, final one is core. As indicated earlier, the earthquake wave's velocity helped in understanding the existence of the core of the earth. The core mantle boundary is located at the depth of 2900 km. The outer core is in liquid state while the inner core is in solid state. Core is made up of very heavy materials mostly constituted by nickel and iron, sometimes referred to as Nife layer. Okay, so this is made up of nickel and iron. So that's why it's known as nephi. Okay, look at this picture. This crust portion, top layer is crust. Then mantle. Okay, this is mantle. And this layer that is the crust plus upper mantle. This is called asthenosphere. Okay, so this is lithosphere. So crust and upper mantle is lithosphere. Look at this crust and uppermost solid mantle. This is lithosphere, this portion. And this is asthenosphere. This is weak area. And this is outer core, then inner core, liquid and solid portion. Now, volcanoes and volcanic landforms. A volcano is a place where gases, ashes and or molten rock material, lava escape to the ground. Okay, so this molten rock material is called lava and that escape to the ground. A volcano is called an active volcano if the material mentioned are being released or have been released out in the recent past. Okay, so then it is called an active volcano. The layer below the solid crust is mantle. It has higher density than that of the crust. The mantle contains a weaker zone called asthenosphere. It forms this that the molten rock material find their way to the surface. Okay, so through this asthenosphere, the molten material come out. Okay. Now, the material in the upper mantle portion is called magma. Okay, so this material in the upper mantle portion, that is called magma. Once it starts moving towards the crust or it reaches the surface, it is referred to as lava. Okay, so the material in the upper mantle portion, that is called magma. But once it starts moving towards the crust or it reaches the surface, then it is referred to as lava. The material that reaches the ground including lava, flows, pyroclastic debris, organic bombs, ash and dust and gases such as nitrogen compound, sulfur compounds and minor amounts of fluorine, hydrogen and argon. Okay. Now, volcanoes. Volcanoes are classified on the basis of nature of eruption and the form developed at the surface. Major types of volcanoes are: first one, shield volcanoes. Bearing the basalt flow, the shield volcanoes are the largest of all the volcanoes on the earth. So these are the largest of all the volcanoes on the earth. The Hawaiian volcano are the most famous example. Okay. These volcanoes are mostly made up of basalt, that is a type of lava that is very fluid when erupted. Okay, so these are very fluid when erupted. For this reason, these volcanoes are not steep. Okay, so these volcanoes are not steep. They become explosive if somehow water gets into the vent. Otherwise, they are characterized by low explosivity. The upcoming lava moves in the form of a fountain and throws out the cone at the top of the vent and develops into cinder cone. Now, second one is composite volcanoes. These volcanoes are characterized by eruption of cooler and more viscous lava than basalt. Okay, so they are cooler and more viscous lavas. These volcanoes often result in explosive eruptions. Along with lava, large quantities of pyroclastic materials and ashes find their way to the ground. This material accumulates in the vicinity of the vent opening leading to the formation of layers, and this makes the mounds appear as the composite volcanoes. Now, caldera. These are the most explosive Earth's volcanoes. They are usually so explosive that when they erupt, they tend to collapse on themselves rather than building any tall structure. Okay, so when they are explosive, they are usually explosive. That when they erupt, they tend to collapse on themselves rather than building any tall structure. The collapsed depressions are called calderas. Okay, so these collapsed depressions are called calderas. Their explosiveness indicates that the magma chamber supplying the lava is not only huge, but it is also in close vicinity. Now, flood basalt provinces. These volcanoes outpour highly fluid lava that flows for long distance. Some parts of the world are covered by thousands of square kilometers of thick basalt lava flows. There can be a series of flows with some flows attaining thickness of more than 50 meters. Individual flows may extend for hundreds of kilometers. The Deccan Traps of India, presently covering most of the Maharashtra plateau, are much larger flood basalt province. It is believed that initially the trap formations cover a much larger area than the present. Now, mid-ocean ridge volcanoes. These volcanoes occur in the oceanic areas. There is a system of mid-ocean ridge more than 70,000 km long that stretches through all the oceanic basins. The central portion of this ridge experiences frequent eruptions. Okay, so the central portion of this ridge, they experience frequent eruptions. Now, volcanic landforms. First one is intrusive forms. The lava that is released during volcanic eruptions on cooling develops into igneous rocks. The cooling may take place either on reaching on the surface or also while the lava is still in the crustal portion. Depending on the location of the cooling of lava, igneous rocks are classified as volcanic rocks and plutonic rocks. Okay, so that is, it's cooling at the surface, then it is called volcanic rocks. If it is cooling in the crust, that is called plutonic rocks. The lava that cools within the crustal portion assumes different forms. These forms are called intrusive forms. Okay, now let's look at some of the intrusive forms. Batholiths. A large body of magmatic material that cools in deeper depth as the crust develops in the form of large domes. They appear on the surface only after the denudational process removes the overlying materials. They cover large areas and at times assume depth that may be several kilometers. These are granitic bodies. Okay. Batholiths are the cooled portion of magma chambers. Okay, so they are the cooled portion of magma chambers. Second one is laccoliths. These are large dome-shaped intrusive bodies with a level base. Okay, they have a level base and connected by a pipe-like conduit from below. It resembles that surface volcanic domes of composite volcano. Only these are located at deeper depths. It can be regarded as the localized source of lava that it finds its way to the surface. The Karnataka plateau is spotted with the domal hills of granite rocks. Most of these now exploited are examples of laccoliths or batholiths. Now, lapolith, phacolith and sills. As and when the lava moves upward, a portion of the same may tend to move in a horizontal direction, wherever it finds a weak plane. It may get arrested in different forms. In case it develops into a saucer shape, concave to the sky body, it is called a lapolith. Okay, so in case it develops into a saucer shape and that is concave to the sky body, then it is called lapolith. A wavy mass of intrusive rocks at times is found at the base of a synclinus or at the top of anticline in folded igneous country. Such wavy materials have a definite contact to source beneath in the form of magma chambers. These are called phacoliths. And the near horizontal bodies of the intrusive igneous rocks are called sill or sheet. Okay, so the near horizontal bodies. Depending on the thickness of the material. The thinner one is called sheets while the thick horizontal deposits are called sills. Okay, so the thinner one, that is called sheets and the thicker one is called sills. Now dikes. When the lava makes its way through cracks and fissures developed into the land, it solidifies almost perpendicular to the ground. It gets cooled in some same position to develop a wall-like structure. Such structures are called dikes. These are the most commonly found intrusive forms of Western Maharashtra area. Okay, So that's about the class. If you have any doubts, you can comment below. For more videos, do like, share, subscribe.